My name is Omer, and our presentation today is about AI and machine learning. What we just heard, those of you that were in the room, was a classic music that was composed by an artificial intelligence virtual artist. Basically, in 2016, it was the first time that the Union of Authors of Right Society has accepted this as a composition and basically acknowledging that it's new, that it has a unique value. And this was the first time, 2016, not too far from where we are today. Now I want to show you a short video of Google CEO, Sundar Pichai, what he thinks about AI. It's a 1-minute video, but since I cannot move forward, we'll also need to see the first 30 seconds, so it's 1 minute and 30 seconds video.
Good morning. Thank you for being here. We're being joined by many people at global launch events around the world, so welcome to all of them as well. We also have a live stream, and so a lot of folks are joining on the live stream, including Dinesh, I'm told. So welcome to everyone. This space used to be a power station for a chocolate factory in the 1900s. So we have transformed it pretty well, but I'm glad we have such a historic setting as we talk about what we are building for the future. At I/O earlier this year, we talked about our vision for that future. We're at a seminal moment in computing. If you step back and think about it, computing has always had big shifts every 10 years or so. It all started in the 80s, early 80s, when the personal computer reached the mainstream. It was the first time computing touched the lives of many people, revolutionized the way they work. Roughly a decade later, in the mid-90s, the web arrived. It is arguably the biggest platform shift we have seen in our lifetimes. It brought the internet to many more people, radically changed industries, fundamentally changed how people interact and connect with each other. About 10 years later, in the mid-2000s, with the advent of smartphone, we had the mobile revolution. That brought computing to probably now around half the world's population. And it's profoundly changing people's lives. And the shift continues. In fact, when I look ahead at where computing is headed, it's clear to me that we are evolving from a mobile-first to an AI-first world. What do I mean by that? In this world, computing will be universally available. It'll be there everywhere in the context of a user's daily life. People will be able to interact with it naturally and seamlessly than ever before. And above all else, it will be intelligent. It'll help users in more meaningful ways. At Google, we are very, very excited about this.
Okay, that's enough. It's a long speech, but actually in the presentation I had to change it many times during the last couple of days because all the time there are news in this area. So the same Sundar Pichai just 3 weeks ago said another sentence about AI. AI is one of the most important things that humanity is working on. It's more profound than electricity and fire. A few more quotes from people are leading the tech industry. So Jeff Bezos, CEO of Amazon, AI development has seen an amazing renaissance and is beginning to solve problems that were once seen as science fiction. Mark Zuckerberg, Facebook. In the next 5 to 10 years, AI is going to deliver so many improvements in the quality of our lives. So many people are excited about it. There are people that are a bit more pessimistic about it. Stephen Hawking, this is the worst event in the history of our civilization. And Elon Musk from Tesla, I have exposure to the most cutting-edge AI, and I think people should be really concerned about it. So we have people having a party, some people are trying to ruin the party, but everybody agrees that there is a big party going on. And why? Why is these days, these last few years, it's such a hot topic? So there are 3 main developments in recent years that contribute to this significant progress, which is real. There is a progress, and we'll talk about it. 3 main areas. So one, that we talk about it many times, the amount of quality data is getting bigger. Our lives are digitalized. And many of the data is kept. But the important part is not just the big data, but labeled data, data that you can feed into the machine and teach it and train it to be smarter. The second thing is that the computer power is also increasing very significantly, and in recent years, research learned to use graphical processing units instead of CPUs for doing machine learning. And if in a regular CPU you have 2 to 4 cores, in a graphical processing unit you have thousands of cores, and it's very effective for parallelism, and it's being used a lot today in new technologies of machine learning and AI. And there are new concepts and algorithms, which the main one is deep learning, that are basically changing the way they did it so far. And basically those three together is what making the revolution. Because deep learning is not something new, but it was not feasible before we had this processing power and before we had this amount of data. And we'll talk about it a little bit in next slides. So what happens in these years, very last years, is things that change the way machine learning is perceived. So things already become some misconceptions about it. Many people believe that when they hear artificial intelligence and machine learning, this is only for AI intense or very focused products, such as self-driving cars and virtual assistants. But in fact, and you will see later on, these are used by many, many other products that are not AI specific. And if you believe in Gartner, I usually don't, but for those who does, they believe that by 2020, AI technologies will be almost in every new software out there, not 2 years from now. Another misconception, and again, it's things that are changing, but that people believe that it's so complex that and you need to invent the technologies or invent the tools to use it. But the truth is that in these couple of years, there are a lot of existing platforms that you can leverage and use for machine learning, and Amazon has Amazon AI, TensorFlow by Google, you have Caffe2 by Facebook and others, and they are basically things that you can just take and use. I'm not saying that anyone is a data scientist, but like the Sundar Pichai, CEO of Google, said, it's changing, and like mobile was 10 years ago, not many people knew how to use it. Same thing is in these kind of technologies. It will be more accessible. So what are we doing today? So I'm going to touch a little bit terminology. We'll be on the same page. What type of things it can do to the business. I'm going to talk about the types of learnings and how to approach machine learning. And we'll see a lot of examples in real world. And if we get time, we'll talk what we can do about it in Zerto. So a little bit of a terminology. So AI, machine learning, deep learning, what's the difference? Everybody using these words everywhere. So AI, but basically, in its broader term, is techniques that enable computers to mimic human intelligence. So you can now start defining what is human intelligence, but basically, almost any program you can say has some AI, because if you say intelligence of a person that does X or Y, so an if else is already doing so. So it's very broad, but machine learning is basically a subfield in artificial intelligence that enables machine to improve a task with experience. So they have more data, they're getting better. This is what's in this machine learning field. Now, deep learning is subfield in machine learning that, we'll talk about it more later on, but basically is techniques that enable software to retrain itself to perform tasks, and it's basically mimicking the way our brain works. So our brain works with neural networks, and basically this is the architecture they use for deep learning, and we'll talk about it later. A few small other terms. In machine learning, when you say a machine, it's basically this black box that you put an input and it provides an output. A model is basically the set of algorithms that you used in the machine and how you calibrate them. This is basically the model of the machine learning that you use. When you have usually machine learning, In most cases, you need to train it. So there is a term training set, basically the data that you feed it when you train it. So for example, let's say we want to build a machine that knows how to differentiate between images of cats and images of dogs. So you take 1,000 images of cats and put it in the machine and say, these are cats. You take 1,000 images of dogs, put in the machine, say, these are dogs. Basically, you trained it with some training set. Validation set is the next data set that you use to see if the machine is working. Eventually, machine provides a probability. What is the probability that this is a cat? Okay, so these are some terms that we may use later, so I wanted to make sure that we are there. So what machine learning could do for the business? So I divided it to 4 categories. I hope it covers most of it. So the first area is to automate humans. So self-driving car, example, you automate the driving. Chatbots, they automate the support people that you chat with. So this is one area that you can use machine learning to. The second area is to customize and personalize the experience for people. So you learn about the people, and then you give them a personalized experience. If we look at the example, you have someone getting into a shop, and without trying the clothes, he stands in front of a mirror, and it fits the clothes on how it will look without trying it out. And also, all the virtual assistants, Alexa, Siri, they're supposed to get to know you better and give you specific recommendation about you. That's where it's going. Machine learning is also used very much for prediction and estimates. So even ways that it gives you the time to go home. It's not always the right time. It's the best prediction. The weather forecast that gives you 60% chance of raining. So we don't know if it's going to rain or not. It's a prediction. And it's used a lot in sales, predictions, etc. And the last area that it's used is to detect unusual activities. This is used very, very much in cybersecurity because you monitor the environment and then you see something fishy going on, and then you understand that there is maybe an attack, or if you see a transaction of a visa that's not the right amount or not the right location, it's an anomaly that is detected with these tools. So before you approach and you want to get into this space or try to do something in machine learning, the first and most important thing is to define what is the problem you are trying to solve. Because in machine learning, eventually machine learning is a set of toolbox. It's a toolbox with many different tools. And even if you don't know, so when you have a problem, you need to say whether I need a hammer or I need a screwdriver. That dictates everything. So you need to understand what is the problem you're trying to solve to choose the right tool. Because it dictates also what is the data that you want to collect that will impact the results. What model to use, which algorithm to use. Everything starts with the problem you want to solve. Okay, now I'm going to get into the different types of learning in machine learning. Now, hope it won't get too difficult, but for those that will listen, later on we'll see examples, and you will be able to see in these examples which one of these tools was used. So there are 3 main types of machine learning. There are more, but those are the main one. Supervised learning, unsupervised learning, and reinforcement learning. So what is supervised learning? Supervised learning is where you teach the machine, you give it data, and you teach it something, and then you test it. So it's like a child learns from reading something. The example with the cats and the dogs, this is an example of supervised learning. We trained the machine with data. There are 2 classic problems that we solve with supervised learning. One is regression, and the other one is classification. Again, I thought it will be a little bit technical, but will be rewarded later on. So regression is a term coming from statistics, and I always like to show examples to make it easier to understand. Basically, it shows you the relationships between variables. So if, for example, in this graph you see, you want to find the relationship between a man's weight and height. So you go and take a lot of people, and you measure the weights and heights. weights and heights, and each one of those people is a point on the graph. You have all this data, and then you want to understand what is the relationship. And in this case, you think it's maybe a linear one. So when you do regression creates this line. Basically, from now on, it's a prediction. Because the next person that will come, if he's 1.7 meters, you will say most probably is around 65 kilograms. So it's basically a way to predict, and it's used very much both in sales forecast, but also in all the health insurance companies. When you go and do insurance, you have to pay a price. Many times they ask you what your age is, because they do analysis, this kind of analysis, to see, for example, how many claims there are per age. So people older have more claims, will pay more for insurance. So they use these kind of models to do these predictions and give you eventually the price you're going to pay for insurance. The classification example is exactly the exact example I provided before. It's a way to divide two categories. So set the example with cats and dogs. Show you some example where it's used today in the market. So for those of you that have personal Gmail, you have these folders, the primary, the social, the promotions. And the way it works is, as you probably know, you didn't configure it. Some emails go there. And that's exactly what they're doing. They're doing classification. They are basically trained themselves on a lot of data, so many emails, to understand which emails needs to go to your primary folder, which are one are social, and which one are promotional. And then they do it automatically. Another example that it's used is in Facebook. Very famous issues with Facebook recently is the elections with the United States and Russian interfering with fake news. So fake news is a big deal now for Facebook, and they're trying to deal with it. But basically, in the essence, in the basic of it, they are doing classification between fake and not fake. So again, they are training their systems to see these are fake posts, these are not fake posts. And this way, because they cannot go post by post and try to understand it, the machine does some of the work, doesn't work so much today. But with reinforcement learning that we'll talk about later, they are improving it. So I'll skip this one. There is a nice exercise that you can play with the machine and actually picture 3 different types of images and then give the machine a new image, and it will show you, will recognize it. So this is if you go to this link, you can play with this classification example. So what is unsupervised learning? Unsupervised learning is learning by observation. Like this kid, you didn't teach it, he's looking around and learning from watching. And few classic problems solved through unsupervised learning are clustering. Again, I'm sorry for the too many terms, but again, we'll get to see more examples. You have clustering, association, and anomaly detection. All of those are types of learning that you don't need to train the machine in advance. So for example, what is clustering? Clustering is you look at all the data and you give the machine like a similarity criteria, one of the attributes, and it groups it by this. So one place it's used. So you go to Google, you search for a jaguar. They don't know if you want the car or you want the animal. So they give you both. But when you choose the image, they have this similar to with more pictures. This is where they do this clustering. They look for similarities based on some attributes, and then you won't see a car there anymore. And again, this is one way they use it, similar to. Now, what is association? Association is the probability that if A exists, B will be there as well. Okay, so again, we'll see examples, so it will be clearer. Let's think about Amazon. You go to Amazon and you buy stuff. You go to and you add items to the basket. Amazon eventually looks at all of these baskets and look which items go with which items, and what is this probability that they go together. And this, they use it to give you this, usually you can see it, frequently buying purchases. So what is usually is bought with this product. So they use association. They just look at all of the things in the basket, see what is the chances that if this exists, the PlayStation exists, then the controller exists, and the game exists. Another example that association is used, very similar to the basket. They see a lot of search sentences in Google. And they see which words go together with which words and what's the probability these words will go together. So when you put the first word, using the association, they give you a recommendation what will be the next word most likely. Hope you're still there. Last one in unsupervised learning is anomaly detection. So basically, you look at the data, like I said before, and you see weird stuff. This is used a lot with Visa and with transactions to see that someone buys with a bigger amount than usual in a different location than usual. Cyber attacks, if someone is doing something to start trying to encrypt your data, many applications. So last one, reinforcement learning, basically learning from trial and error. The machine does something, you tell her it's right or wrong, and it improves in time. I'm going to show you one example here. So when you go to Google Translate and you write a sentence, they have this suggest and edit. So if the translation is not very good and you suggest something better, and many people suggest the same thing better than the original one, basically we are reinforcing the algorithm, and they change the translation. Now I'm going to show you a video of how reinforcement learning is used in gaming. So you have a game, the people that are not very young will be familiar with this game. And the machine starts with no data at all. You just have one thing that they taught her, that it needs to maximize the score. So we'll see the video. It will learn from playing without any previous data. I don't know how many people played with this one in the past. But as you can see in the start, it has no clue what to do. But when he sees the balls falling down, it understands that he's losing points. So let's keep the ball in the game. After 120 minutes of playing, he got it. And you can see it playing like acing. But the interesting part here is what happens next. Everybody that plays this game knows that what is the real fun part of this game. And you will see it in a second. So it trained a lot and got more knowledgeable, and then the magic happens. Basically, it understands that it needs to dig a tunnel to go and break it in the top. So here's the tunnel. So as I said, people that played with it know this trick. So as you can see, it played and learned and got better. Okay. Again, it's a little bit intense, but the deep learning, as I said, our mind is built with neural networks, and researchers took the structure of it, decided to build a network of machines. And basically, the way it works, so I'll give you an example of face recognition. So in the past, face recognition, the way it worked, you would look on the face, different angles, look at the different, the distance between your different parts of the face, but we look on the face. What deep learning does, it works in layer. So you have the input layer, then you have the hidden layers and the output layer. The reason they call it deep learning is because of these hidden layers, because in the past you had only input and output. Now you have additional layers, so it's deeper. So just to understand it. So each layer here looks at the picture from a different abstraction level. So there is a layer looking only on the pixels, so if they're dark or light. There is another layer looking at different pieces of your face, your ears, your eyes, your nose, checking each one of those if it's yours or not, and only then going to the layer that checks the entire face. And as I said, with a lot of computing power and a lot of previous data, they're getting much better results than ever before. So in traditional machine learning, there was a point where more data didn't give you more performance. You got to this peak, and with these neural networks, you get much more performance, better performance, if you have more data. Okay. So now a very nice story. Lee Sedol is the world champion in the game of Go. Game of Go is considered a much more complex game than chess, even though it looks simpler, but it's much more abstract. And this was something that many years they tried to beat, tried to build a machine that will beat someone in that. And again, in 2016,
Go is the world's oldest continuously played board game. It is one of the simplest and also most abstract.
Beating a professional player at Go is a long-standing challenge of artificial intelligence.
Everything we've ever tried in AI just falls over when you try the game of Go.
The number of possible configurations of the board is more than the number of atoms in the universe.
AlphaGo found a way to learn how to play Go.
So far, AlphaGo has beaten every challenge we've given it, but we won't know its true strength until we play somebody who is at the top of the world, like Lee Sedol.
A match like no other is about to get underway in South Korea.
Lee Sedol is to Go what Roger Federer is to tennis.
Just the very thought of a machine playing a human is inherently intriguing.
The place is a madhouse.
Welcome to the DeepMind Challenge.
The whole world is watching.
Can Lee Sedol find AlphaGo's weakness?
Ooh.
Whoa. Is there, in fact, a weakness?
The game kind of turned on its axis.
Well, look at his face.
That is not a confident face.
It's developing into a very, very dangerous fight.
Ooh, hold the phone. Lee has left the room.
In the end, it is about pride.
I think there's something went wrong.
Yeah, it's made a mistake. He's got to pronounce a miracle.
These ideas that are driving AlphaGo are going to drive our future.
This is it, folks.
So this was, again, 2016. It's 141. But the interesting thing is that the way they did it, they trained the machine to look at a lot of players, amateur players and then professional players, and go and learn and eventually play against itself to get to this level. But a year after this event, they produced and released a new version of the system, AlphaGo 0, which basically was trained from nothing, just from the rules of the game, and was already beaten the AlphaGo that we just saw that beat the world champion. So there is now an unbeatable machine in space. And basically, I think this is the one of the most, this is the things that people are worried about, that there is the best people in like the best one in the world, there is a machine that beats it. Elon Musk, that's one of the things that he's worried, that in other spaces can be dangerous. I'm gonna skip this one. So after I hope you remember some of the tools I discussed in the types of learning, because now we're going to see this magic in more real-life examples and try to see if we understand how it works. For those of you not familiar, Tinder is an application for dating. Very, like the young people use it, so very primitive. You see a girl's image, you like it, you swipe right. You don't like, you swipe left. Same thing the girls do. And if both people swipe right, you start a conversation and go on from there. So what Tinder did, it's not an AI product, but what they did, they added a smart photos feature that basically looks at all the pictures that you put in the application, look at how many of those are getting, the right swipe, and basically later on, after they understand, every time they put your face, they put your best photo based on the previous results. So if we're trying to understand from all the things I've showed before, all the learnings, which type of learning is this? So I'll help you with the first one. So basically, this is reinforcement learning. It learned from the mistakes. It saw swiping right is good, swiping left, the image is not good, and it reinforces itself until it gets better and shows the right picture. Another very famous example is Netflix, which is one of the pioneers in this area. More than 80% of TV shows on Netflix are found through its recommendation engine. And they estimate the ROI of this recommendation engine is €1 billion a year. Now, what do you see here? You see, because you watched Orange is the New Black, we give you this list. What does it sound familiar with something we talked before? Okay, so I'm cheating a little bit because eventually they are using many different algorithms here to solve this problem, but they're using both categorization and association from the list I showed you before, because basically they, like the basket case, they see that someone saw movie A, movie B, movie C, they see that the movies are associated, and then when you see movie A, they give you most likely you want to see maybe movie B or movie C. And categorization, they also categorize the different videos into different genres to also find those matches. For those of you that use Apple, this is a nice feature in iPhone, that after you start writing your email, it starts suggesting you who else you should add to the email. So again, this is using exactly the same technique that we talked about. So again, association. It looks on all the emails you write, the groups of people in the two email, and then they see what is the chances that if Eti is in the email, Chen will be in the email, and if they both are there, what the chances that the third one? So they just look at all your emails and do this association trick. In Google, there is a different feature. This is smart replies. So someone writes you an email, and then they give you an option to give an answer. Don't write it. Let's do Monday. Monday works for me. Either day works for me. So here, from what we talked before, again, I'm not going to there is one aspect of text analytics that are understanding the meanings of the text, but there is the aspect of what happens if I don't use it. If I see none of the options is good for me, and this is again reinforcement learning, because if I don't use any of the options, they understand maybe they're not very good options, and if I use, the option gets higher score. This is Pinterest, an application for lifestyle with a lot of images there, and they did something very nice recently. So they allow you to search by images. You take a picture of an image, and they give you things that are related. What are they doing? So the first part is object detection. They understand what's in the image, and they give labels to it, so shoes, red, etc. But then look, they give you options of what will go with these shoes, what types of clothes you can use. Many people use it for furniture in the house, so they picture a table, then it's one friend, they picture the table, they give them many options that the same lifestyle. And here it's clustering, because we don't have a previous image, but we use this as similar criteria. So we want the machine to group the data by some attributes, so it's red, you choose, etc. Okay, another nice example from very recent months. Those of you that are not familiar with Amazon Go, Amazon opened a shop in Seattle that you just go in, take what you want and leave. I'm going to show you a video, and we'll talk about it.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it just walk out technology.
Okay.
Once you've got everything you want.
Wait, go back yet. Okay, so let's think about how they do it, Amazon. So again, this shop is already available in Seattle. People go in and out. So a lot of people trying to cheat the system. Didn't see anyone succeed yet. And that's very interesting how they do it. So eventually, this is not only the machine learning and the types of things we talked about, but there are other things they do. But first of all, when you go in, you show your app. They know that you are in. Based on your account, you are inside. They have on the ceilings of the shop more than 100 different cameras taking pictures and videos from very different angles of the entire shop all the time. Now, they do this video deep learning algorithms for image recognition, like we talked, with very good performance. But when you go and you pick something, so the first thing, each item there, and you didn't see it in the video, the barcode is very, very big. So the video also sees the barcode. And in addition to that, they have sensors with weight that every thing that you pick up, they know that you picked it up. And if you, so I saw an example of someone picking something and put it in the wrong place to try to confuse the system, but it didn't confuse because they have also weights and sensors, and they see where you're going. And all of those together eventually give a probability that you took the item, you put it in the basket and went out. And eventually this works. I don't know if this is going to be the trend, but eventually it's just out there already in Seattle. There's only one shop yet that's trying it out, but looks like amazing technology, and it's basically taking a lot of technologies together to make sure that not only watching you go, and not only the sensors, and all of those together needs to bring them very, very high confidence before they can lose money if someone takes something. Okay, so we saw it. Okay, another area that's going to, I think, going to be the most interesting area that we'll see advancement in is healthcare. I'm going to tell you a short story. A few years back, I played basketball, and I broke my leg. So I went to the emergency room in the hospital, Haifa, and I did the X-ray. And I came to the doctor and said, okay, so you need operation. We need to give you screws, something serious. Okay, and luckily me and my father is a doctor, so I am nervously picking up the phone and calling him. And he's at the same time in Ichilov in Tel Aviv, telling me, get out of the hospital, takes the X-ray, take a taxi, and come to Tel Aviv. So I'm with a broken leg on a taxi to Tel Aviv. I'm getting to Tel Aviv. My father is waiting for me with a specialist of ankles. The guy looks at the same X-ray that the other doctor looked at. He says, no, we just need to give you a cast. Give us cast on the leg, 3 months, and that's what happened. So I was saved from something more serious. And many people here know it and probably experience something that when you do an MRI or do an X-ray, you do something, many times you go to second opinions. Because not all the doctors see all the things the same, even though it's the same image. Now, in these types of technologies that you can train the system to find things in the data, and you see a lot of data, these are areas that the machine can be better than the best doctor. And it's not that they're going to replace doctors, but we'll see in the coming years doctors using tools like that to help diagnose. Now, Google already is starting to get into this space, and you will hear in the coming year or two more companies doing projects with hospitals and healthcare. So there is a disease called diabetic retinopathy. Also didn't know it before. So the interesting part of it is this, it's the leading cause of blindness in the world. And another interesting part is that if you find it early enough, you can prevent it. Now, Google used their machine learning technologies like we've seen, and we're basically able to detect this disease in early stages. And now they are already wrote a paper on that and starting to promote this technology, and they're trying to work with hospitals to promote it. But one of the problems was that people would get to the doctor too late. Not always there is a doctor that knows how to do it. Now they are promoting this product that will help doctors do it. Another area in healthcare that will be used is to probably find tumors. And it's not far away from us, these types of advancement. So this is another, I have one more slide that I added yesterday with help of Ilan. So this is actually an Israeli startup called Gong. And this is actually a product that we're using in Zerto for our salespeople. What is Gong? Basically, it listens to all the sales process. It listens to our salespeople talking with customers, and it identifies what works, what they say, and what doesn't work. And they also recommend the people in real time what to say, what not to say, basically helping, I would say, helping weak salespeople become like the best one. And what's interesting about this example is that, at least Gong, that's what they say, that when they trained the system, they took all the episodes of Seinfeld as the training data, as one of the training data to teach the machine about humor and awkward moments and things like that to basically help understand better and teach the machine how to react in this kind of, and identify this kind of activities. Okay. So now, basically, is the part that what we can do about it in Zerto, and I have two slides. One slide was an empty slide, open question, and the other slide is all the ideas that I could think about. And since I have time, so what the heck, I'll show you some of my stupid ideas probably, but this is the part I'm less confident about. So I said in the early stage that there are several places, areas that you can use machine learning. So one of those was forecast. So some of the examples, probably there are many, many more examples, but to predict the failover time window. So we know that when you do failover test, at some point you will run out of storage. To show customer the expected growth rate of storage of one, RPO trends, some what-if scenarios, what happens if I change the history, the journal history, what will happen to the journal size, to try to forecast pricing for the customers if they try to move VPGs to the public cloud, a lot of these areas. Now, I've been trying to think what is the perfect disaster recovery product. If I had the ideal world, what will be the perfect one? For me, the perfect disaster recovery product is something that after you configure, you don't ever touch it again. Only when the disaster happened. You don't deal with errors, and that you put it once, and it's there only for the emergency. You don't want to deal with it. Now, our product is not there yet because many times you have errors and alerts and things that you need to configure. Anything in that area that we could do to solve ourselves and not let our customers solve is a progress. If VPG gets into error state and we could either prevent it or get it out of there, that's a good thing. If we can do movement of VPGs and balance the resources. A lot of ideas, again, I'm not an expert on these parts enough. Another area is unusual activities. We can find unusual activities that happens if it's disconnections, RPO anomalies, so the relevant volumes. We can get into the space of security. If we could look at the IOs and see anomalies there that shows that, for example, someone is trying to encrypt the data, something is not typically is happening, and use it. And the area of personalization. So anything that we can learn of how the user uses the system to make it more tailor-made for the user, give him recommendations for settings that fit this user, give him recommendation based on other users doing, based on their environments, things like that. This is the other slide that I'm not doing it, so already, so give the example. So I'm going to give you a last last video to basically finish this session with something nice. So Boston Dynamics is a company that does robotics. Was acquired by Google and already sold. And let's see the video, better than anything I would say. Basically, I'm showing this video not because it has a lot of AI in it, but it shows the progress we also see in technology in robotics. There are many, again, technologies here, not only machine learning. Most of it is like, we have obviously image recognition, as it moves. By the way, they have a lot of different robots. This is one of them. If you like this video, you will be able to see more types of robots. So they have, as I said, many different examples. This is a field that also is progressing. Different versions, different types. And you can YouTube Boston Dynamics and you'll see other types of robots. This is, again, if you pay attention to the lecture, you see that all the examples I give you here is from the last 2 years. Okay. Okay, so I'm getting to the end. I want to summarize a little bit. So, few takeaways. So AI and machine learning are experiencing a huge development these days, and it is really the start. We'll see a lot of it. Since I started working on the presentation, every day I saw something new. As we saw, can use in many different applications. There are more. I didn't put all the examples I saw, but not only AI related. This is something that, not exact right, but I think that, as I said before, like in mobile when it started, like when the internet started, eventually when this will progress, if you believe the people who saw in the beginning, many people will get in the field and will become with this knowledge. And, but you can already start. There are a lot of tools that you can already start to participate. When you want to work with machine learning, you first define the problem, choose the right data to use, then you choose the algorithms, and eventually you also need to think of how you expose it to the user. You don't give him a probability. You give it, find a way to wrap it for the user, and think where we can use it in Zerto, each one in the area that is working on. And also pay attention when you see examples if you can recognize what's going behind the scene, what is the magic. Thank you very much.